Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to provide examples of application problems using geometric sequences. So here what we're looking at, this is number 16 on your handout here over geometric sequences. In the application section it says, basically, a lab sample contains 600 milligrams of radioactive material with a half-life of 1 hour. How much is left at the beginning of the 5th hour? So first of all, I should talk about what half-life means. So, radioactive material is material that decays off. The atoms actually come apart and break into smaller atoms, and the original material is gone. The half-life is the time it takes for half of that material to disappear. So in this case, however much we start with, after 1 hour, half of it will be gone. So I'm going to go ahead and write out some of the terms in the sequence here. So we're starting with 600 milligrams. I'm going to just put the units over here. And then after 1 hour, we would have 300 milligrams, right? And then another hour, 150 milligrams, and then 75 milligrams, and then 37.5 milligrams, and so forth. So this is an example, again, of a geometric sequence. I'm going to go ahead and write out a formula for the nth term. The nth term is going to be our first term, 600, times our ratio, which in this case is 1/2 to the n minus 1. Now keep in mind that this first term here is for n equals 1. And it says, let's see, to answer the question, at the beginning of the 5th hour. So I would say that this one right here is the beginning of the 2nd hour. And you'll notice here that n is equal to 2. And then beginning of the 3rd hour, beginning of the 4th hour, beginning of the 5th hour. This should actually be the answer to our question here. And notice that here n is equal to 5. I'm going to go ahead and use our formula here to calculate it. And if we do 5 minus 1, we end up with 4th power. And again, I know that I'm sure this is our answer right here, but if these things are really long, you want to be able to calculate the nth term using our formula here. So let's see, make sure that this works. Okay, and I get 37.5 grams out of that. Or I'm sorry, 37.5 milligrams. All right, I'm going to call that one good. I think what I'll do is pause the video here while I set up our second problem. All right, I'm back here and I've written down some stuff here. I shortened it up a little bit, but basically in this problem, which is number 17 on your applications page, it says a Facebook post is sent to 10 people who then send it to 10 people, each of which who send it to 10 people, etc. We're going to look for the total number of people that have had that post after 4 cycles. When I'm dealing with sequences, I always start by writing out some terms here. So that first one is 10. And now if these 10 people send it to 10 people, now we're going to have 100 people who have that post. If these 100 now send it to 10 more, now we're going to have 1,000, right? And then 10,000. And then the next one will be 100,000, and so forth, out till, say, a sub n here. All right, the a sub n, right, this being a geometric series, or I'm sorry, sequence, is equal to 10 times our ratio to the n minus 1. And again, our first one here would start at n equals 1. Now what we're looking for is the total number of people who have received that post. So that's going to be the sum out to some value here. So that's what we call s sub n. I'm going to go ahead and write this out. That's going to be 10 plus this one is 100 plus out to our a sub n here, whoops, which I'm going to go ahead and use this formula for, 10 times 10 to the n minus 1, right? Now remember our little trick here, multiply both sides by r being 10 in this example. So the next line is going to be 10 times s sub n equals, this will become 100, this one will become 1,000. All right, the very last one, when we multiply this by 10, is going to be 10 times 10 to the n. And again, that's coming from multiplying this guy by 10. All right, then remember the next step of our trick. Take equation 1, subtract equation 2. So we're going to take this minus this. We're going to minus 9 s sub n equals. Now over here on the right, if you notice here, we got what I call these like subtraction partners. Here, 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 the very last one. This very last one will have one with the one before it. So everything is gone to the right of this 10, and everything is gone to the left of this term. The two things that survive are this and this. And keep in mind, we're subtracting this second equation. That's going to make this minus 10 times 10 to the n. All right, now we're going to answer the question here after 4 of these cycles. So this is right here would be after 1 cycle, 2 cycle, 3 cycle, 4 cycles. You always have to make sure your n values corresponding correctly, because that'll depend on how you're starting these. So this one's for n equals 1, and then this would be after 1 cycle. So that's here n is 2, and this is another cycle, n equals 3. So you'll notice after that the n value is larger than the cycle value, so to speak here. So if we're looking for after 4 cycles, we're going to want to use n equals 5. Right? This one's n equals 4. This is n equals 5. Right? 1 cycle, 2 cycle, 3 cycle, 4 cycles. All right, so minus 9 times S5 is going to equal 10 minus 10 times 10 to the 5th power. And now it's just a matter of solving for this. So I'm just going to run this through a calculator, divide by the negative 9. And see what I get. All right, I got 111,110 people. Make sure I counted this right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep, we're good. All right, so I think what I'm going to do here is call this good on this video and just start a new one for the next set. Have a great day.